Hello, welcome to another module in this massive open online course on the principles of CDMA, MIMO, OFDM wireless communication system. Today, let us look at another interesting aspect of a CDMA communication system. Previously, what we said is that in a CDMA communication system, each symbol is multiplied with a code. For instance, let us say I have a symbol A1 of user 1 that is multiplied with the code 1 minus 1 minus 1 minus 1 to generate the samples A1 minus A1 minus A1 and A1. These samples, these are also known as the chips. In the context of CDMA, these samples that are generated for each symbol, these are also known as chips. Therefore, what we are doing here is that we are generating 4 chips, that is n, which is the length of the code, equal to 4. So, we are generating n equal to 4 chips per symbol. Right. So, for in this simple example that we had considered previously, for each symbol A0 we are generating 4 chips, for symbol A1 we are generating 4 chips. So, we are transmitting 4 chips per each symbol. Now, consider a simple example in which, let us say, my symbol rate, consider a simple example in which the symbol rate equals 1 kilobits per second, implies basically there are 1000 symbols per second. So, we are transmitting, let us say, 1000 symbols every second. The rate is 1 kilo symbols per second. If we are transmitting 1 bit per every symbol, then it will be 1 kilobits per second, which implies the symbol time, the time per symbol. Therefore, this implies that the time per symbol equals, the time per symbol is equal to 1 divided by 1000. Since you are transmitting 1000 symbols per second, the time per symbol is 1 divided by 1000, which is equal to 1 millisecond. So, our symbol time, our Ts, which is equal to symbol time, is equal to 1 millisecond in this system. Also, the symbol bandwidth, the bandwidth of the symbol, since the symbol rate is 1 kilobit per second, the symbol bandwidth, the bandwidth required is, the bandwidth required for this system is equal to 1 kilohertz. Since we have, basically we have symbol rate of 1 kilobit per second or 1 kilo symbol per second, the bandwidth required for this system is 1 kilohertz, right. This can also be seen from the symbol time. Symbol time is 1 millisecond, therefore, bandwidth is 1 over 1 millisecond, which is 1 kilohertz. Therefore, the bandwidth equals 1 over Ts, which is equal to 1 over 1 millisecond, which is equal to 1 kilohertz. Okay. So, the symbol time is 1 millisecond and bandwidth is 1 kilohertz. Now, in a CDMA system, what we are doing is we are transmitting n chips, or n is equal to 4 chips. In this specific example, we are transmitting n equal to 4 chips per symbol, which means if the symbol time Ts is equal to 1 millisecond, the chip time Tc equals 1 millisecond divided by 4, because we have to transmit 4 chips during the symbol time. Therefore, the chip time Tc equals symbol time Ts divided by n, where n is the number of chips, which is 1 millisecond divided by 4, which is equal to 0.25 millisecond. Therefore, the chip time is 0.25 millisecond. Alright, since we are transmitting n chips per each symbol, the chip time is symbol time divided by n, or in other words, for this example is 1 millisecond divided by 4, that is 0.25 millisecond. Therefore, now the new bandwidth of the CDMA system is 1 over the chip time. Therefore, bandwidth of CDMA system is 1 over the chip time, which is 1 over 0.25 millisecond, which is basically equal to 4 kilohertz. So, therefore, the bandwidth of the CDMA system is 4 kilohertz. What we had seen previously is that the bandwidth of the system is 1 kilohertz. Now, in the CDMA system, because you are transmitting more and more chips per each symbol, the bandwidth has increased to 4 kilohertz, and therefore, the bandwidth required for the CDMA system, and this can be expressed pictorially as follows. So, let us say we have an original signal which has a bandwidth. So, this is my bandwidth of the original signal, which is the bandwidth of the original signal, which is 1 kilohertz. This is the original signal. The bandwidth of the new signal, that is the CDMA signal, is 4 kilohertz. This is the bandwidth. The bandwidth has increased. The bandwidth of the CDMA signal equals 4 kilohertz. So, this is the bandwidth of the CDMA signal. So, multiplying by the code has resulted in an increase in the bandwidth of the CDMA signal, or the bandwidth of the original signal is 1 kilohertz. This bandwidth has been spread to 4 kilohertz. So, the bandwidth of the original signal is spread in a CDMA communication system. So, what we are observing is that the bandwidth of the original signal or the spectrum of the original signal, bandwidth or the spectrum, this can also be called as the spectrum. Spectrum of the original signal is spread in a CDMA system. Therefore, the CDMA system is also known as the spread spectrum system. It is also known as the spread spectrum system. Therefore, CDMA system is also known as a spread PDMA system is also known as a spread spectrum system, and this is the key word, because the bandwidth of the original, which is 1 kilohertz, is spread by a factor of n, that is 4 times, to become 4 kilohertz. In general, if n is the length of the code, the bandwidth of the original signal is spread by a factor of n. So, code length is n. If code length is equal to n, then bandwidth or spectrum is spread by a factor of the spectrum is spread by a factor of n. Therefore, the code in CDMA is also termed as a spreading code. Therefore, CDMA codes are also termed as therefore, the codes in the CDMA system are also termed as spreading code. So, what we have seen is the following thing. Since we are transmitting multiple chips per each symbol in a CDMA system, this results in a spreading of the bandwidth. The resulting bandwidth of the system increases. Therefore, CDMA is also known as a spread spectrum system, and these codes which spread the bandwidth of the signal in the CDMA system are also termed as the spreading code, and this factor of n is also termed as the spreading factor. The length of the code n is equal to the spreading factor. Length of the code n is also equal to the so the length of the code n is also equal to the spreading factor in this spread spectrum CDMA system. So, this module basically explains what is the reason behind calling CDMA as a spread spectrum system, and how do you design, and what is the impact of the length of the spreading code on the CDMA system. We will stop this module here, and we will look at other aspects in the subsequent modules. Thank you.